When it comes to a neuron's excitability, the whole excitability process is dependent on sodium influx. And when it comes to sodium influx, it is all about voltage gated sodium channels, guys. It is all about voltage gated sodium channels. Alright. Now itself be aware of this one point. If a neuron has to get activated, if a neuron has to turn functional, the neuron must be excited first. And who does that? Entry of sodium. Through what? Voltage gated sodium channel, doctors. And the whole neuronal function, brain function, spinal cord function is dependent on this very simple one property, where sodium enters through voltage gated sodium channel, causing depolarization of the neurons. Now my friends, let's go on to study each and every structure in a neuron. We begin our discussion with dendrites. Now dendrites are the one which receives synaptic connection from presynaptic neurons, people. Dendrites receive synaptic connections from presynaptic neurons. Majority of the synapses, alright, are either of two ways. It will be either a chemical synapse or a electrical synapse. People remember this. Synapse is nothing but a mere connection between two neurons, right? And that connection exists in two formats. Two neurons can be physically connected to each other through a junction called as gap junction, or a neuron will be communicating with another neuron in the format of a chemical called neurotransmitter. Alright. So the way two neurons speaks to each other are either electrical or chemical. Electrical communication is by gap junction and chemical communication is by neurotransmitters. In this topic of dendrites, let's study the chemical transmission and let us study the electrical transmission separately. Alright people, now put your best focus on the chemical transmission and what is going to happen. So guys, let me take up a presynaptic neuron here. Consider this as a presynaptic neuron, and this is going to be the axonal button of presynaptic neuron. The postsynaptic neuron has its dendrites. And you know that dendrites do have a projection called a spine, right? Now let me give you the idea of how a spine arranged in a dendrite, people. Consider this as the spine belonging to a dendrite. So this is the spinous process, and this spinous process is located in dendrites of postsynaptic neuron. Now how does this two neurons involves in communication? The spinous process of postsynaptic neurons do have a receptor, and this receptor is nothing but ligand gated channels. People, please remember, the spinous process has got a receptor, and this receptor is nothing but ligand gated channels. Now it can be practically anything. Alright, in a simpler terminology, the word ligand refers to neurotransmitters, right? Be clear, the word ligand refers to neurotransmitters, which means the presynaptic neuron can able to release any kind of neurotransmitters. Consider this as a vesicle. Inside the vesicle you are going to find multiple neurotransmitters, people, and with the right amount of calcium inside the presynaptic neuron, the vesicles are going to be brought close to the postsynaptic neuron, and there is going to be fusion of the vesicle. Once the vesicle fuses with the postsynaptic neuron, there is going to be a gradual break in the neuronal membrane. As a consequence, the stored vesicle will be released into the synaptic cleft. When these vesicle comes and gets released into the synaptic cleft, the neurotransmitters will touch the ligand gated channels. Depending on the neurotransmitter, the channel may be different.